Understanding and correcting parallax. View of an isolated sniper scope from the parallax adjustment turret side. You see the term often used when describing scopes, but what exactly is parallax? More importantly, do you need to concern yourself with the parallax settings of a scope? What is parallax? Parallax describes a situation where the focal plane of the object in the scope is offset from the reticle. If you have parallax, you have an optical illusion that must be corrected. This should not be confused with focus. Parallax compensation changes neither the focus of the reticle or the focus of the image, it simply moves the planes at which these two objects are in focus so that they share the same plane, are coincident. When looking through a high-power scope, you identify parallax by adjusting your gaze slightly. If the reticle changes position on the target when you shift your gaze, your parallax is not properly compensated for at that range. The reticle appears to move in relation to the target image because the focal planes are not coincident, making it appear to be a 3D image. Properly adjusted, the reticle appears locked in place as if it were painted onto the target so that no matter how your gaze is shifted, the reticle position never changes relative to the target. When shooting long distances, it is important to account for parallax. Parallax examples. The point where the focal lines cross and form an X is the focal plane for the target image. This is in front of the reticle. When the angle at which you are viewing the image through the eyepiece changes, the reticle position relative to the target image changes. When the focal plane for the target image and the reticle are the same, no parallax adjustment is necessary. It is possible to have an accurately placed reticle in the first scenario if you are looking through the scope with your line of sight exactly lined up with the reticle and target image. The problem occurs when your line of sight is not exactly lined up, as the point of aim indicated by the reticle is now incorrect. By eliminating parallax and having the target image and reticle on the same plane, you no longer have to have a precise line of sight. No matter what angle you are looking through, the scope at the reticle will still accurately indicate the correct point of aim. Parallax is usually negligible or not present at all in most low-magnification tactical style scopes, as the scope is too short or the range is not long enough. 1x red dot style scopes generally are parallax-free at any range. Even mid-power hunting scopes have very little parallax, and many tactical models do not have parallax compensation, as it is impossible to quickly and accurately determine range in a dynamic tactical situation. In high-power scopes used over long distances, you must compensate for parallax. High-power scopes are usually equipped with a side-mount turret, or adjustment ring located on the objective bell, so you can move the focal plane of the target and reticle and eliminate parallax. Some of these rings or turrets are marked with various distances, generally ranging from 50 yards to infinity, indicating the proper setting to eliminate parallax. While helpful as a general starting place, these factory set markings are not always accurate. I find it helpful to manually determine the proper setting at 50-yard increments and mark those settings on the scope. Why is it so critical to get a precise compensation setting? Because the amount of parallax increases with magnification, giving you a larger margin of error at higher powers if it is not precisely corrected. For example, on a high-power variable 6-20x magnification scope, parallax appears easy to compensate for at the lower 6x magnification setting. Once the zoom is increased to 20x, it takes a very fine adjustment to completely eliminate it. Measuring compensation. To measure the actual parallax compensation needed for a given distance and zoom, head out to a range with known distances and calibrate your parallax adjustment mechanism. Some adjustment systems, such as a side-mounted turret, have knobs you can use to re-zero the mechanism. To get consistent compensation, start with the adjustment knob or ring set on the stop past infinity. 1. Make sure your scope has been zeroed for your rifle. 2. Set up the firearm in a stable configuration aimed downrange at your target using sandbags or a machine rest. 3. Make sure your target is the maximum distance possible at your shooting range. Preferably this is 1,000 yards, although shorter distances also work. 4. Set the magnification to the maximum. 5. Sight through your scope. 6. Slowly shift your gaze while looking for movement of the reticle in relation to the target. 7. Use the parallax compensation turret or objective ring to adjust the focal planes until there is no movement of the reticle when you shift your gaze. 8. Use a fine paint marker to mark the point on your ring or turret for this range. Conclusion: Parallax. You can continue this process at various distances by moving the target closer and repeating the process. Permanently marking the positions on your ring or turret makes it easy to consistently return to that point time and again. Remember, when adjusting parallax using a side mount turret, always start with the turret set against the stop past infinity and then turn it to the appropriate setting. This ensures that there is no slack or backlash to throw off your adjustment.